Okay, hello everyone. This is the video related to tacheometric surveying in which we find the horizontal distance between your instrument and the leveling staff and the vertical height of that particular point from the horizontal axis of your instrument. Then based on that we can calculate the elevation of the point Q. Okay, if we have a RL of the HI. So here you can see that in the figure, here we have a instrument P is fixed at the location P, and here we have a object Q, that is the staff location. From the location P we fix our instrument and observe the angle theta, that is the vertical angle, and here we have a leveling staff, that is the observe, and we observe the reading upper, middle and the lower, okay, from the crosshair, and that will be used to calculate the staff intercept. Okay, staff intercept means upper minus lower, that is the difference between staff reading, that is the upper crosshair minus lower crosshair. Now from that we need to calculate the horizontal distance between P and the Q and the vertical distance from this horizontal axis of the tacheometer, that is V. We have an equation for the vertical distance, V equal to 1 half Ks sin theta plus C sin theta, and for the horizontal distance D equal to Ks cos square theta plus C cos theta. And if we have a elevated, here you can say this angle is the elevation angle. So we have a positive angle, and for that we can say that is the leveling staff is fixed on the elevation angle at particular point Q, and for that we are going to calculate the RL of this particular point. So if we want to calculate the RL of this point, we require the RL of this point, that is the axis of the telescope or line of collimation. Okay, you can consider it as a LC, that is the line of collimation. If you know the elevation of this line, then we can easily calculate the RL of the Q, and for that if you didn't know, simply you need to fix your instrument at a benchmark, so you know the RL of this point, then you can add the H, and then we calculate the line of RL of our LC, and then we add the vertical height, and then it gives us the elevation of the point Q. So here we have equations of the elevation of the staff station for the angle of elevation. So here you can see that the angle elevation of the leveling staff, when we fix, there is a elevation angle. So elevation of the instrument means where we fix our instrument location, plus h that is your height of the instrument, plus we can find using the equation, that is the formula generally we use, plus or minus r, that is the center crosshair reading. Okay, so using this formula you can find the elevation of the point Q. Okay, if the RL of line of collimation is given to you, you can skip this 2 point and directly write down the RL of LC, line of collimation, that is the LC plus V minus R. Remember, the R means that is the center reading, or you can say the middle reading. It always subtracted, okay, from the vertical height when we observe the reading, whether it will be a angle, depression angle or a elevation angle. Next we have a figure of the depression side, okay, where your point is below your line of collimation. So when we have a point Q here, you can see that we have a point Q here, that is the below the line of collimation, and we fix our instrument at a P. This will be your, you can see the vertical angle theta, and it is a depression angle because there is a point P at a lower level compared to the line of collimation. So here you can see the same procedure will follow. The equation also will be remain same. That is the vertical distance V is equal to 1/2 Ks sin theta plus C sin theta. Here will be sin 2 theta. Okay, and Ks cos square theta plus C cos theta. So that will be equation. There is a smaller correction in the equation of the V, that is the 1/2 Ks sin 2 theta instead of sin theta. Okay, so let's make a smaller corrections. Then Ks cos square theta plus C cos theta, that is the equation. The equation will remain same. For the vertical distance, it will be for the angle of elevation or angle of depression. There is a normal change in the elevation of leveling staff. If we have a angle of depression, here you can see that there is a slightly change elevation of the instrument plus h minus v. Look at here, in the elevation we are going to add the vertical height, but in the depression we are going to subtract the vertical distance, and r always we are going to deduct from that vertical height. So this is the formula that we use to calculate the elevation of any point using the, you can say, the tachyometer. We first calculate the horizontal distance, then vertical distance, then using the RL of any instrument or RL of any point, we calculate the line of collimation, and then if we have a elevation angle, we add the vertical height. If we have a depression angle, we are going to deduct the vertical height. And always remember, R value is always deducted if we have a positive angle or a negative angle, means depression or elevation. Okay, now the next example here, one of the example is given to you, that is the tachometer was set at a station A and reading on the vertically held staff at B, means our instrument was fixed at station A and the leveling staff held at B, and we observe the reading. There is upper reading is 2.255, middle reading is 2.065, and the last reading, or you can say lower reading, is 2.955. Again you can see that the line of sight, the inclination is given to you, that is the 8 degree 24 minute. Plus sign indicate elevation angle. Another observation on the vertical held staff at a benchmark is observed. So simply first reading is observed at a B station, another reading is observed at a benchmark, and for that here you can see that the 3 reading is observed, that is the upper, middle and lower again, and again there is a line of collimation is given to you, that is the 1 degree. The angle with the line of collimation is 1 degree and 6 minute. That is also plus, means indicate the elevation angle. Now you need to calculate the horizontal distance between A and B and the elevation of B. If the benchmark is given to you, that is the 148.685. Okay, and the constant is given to you, that is the 100 and 0.3. Remember, if the constant is not given to you, you need to consider that 100 value for the multiplying constant and the additive constant. Multiplying constant consider as a K and additive constant consider as a C. Okay, so now always remember, the first step is always we need to first calculate the line of collimation, that is the RL of line of collimation. Okay, to calculate the RL of any point, so first we calculate the staff intercept, that is the upper minus lower. So for the upper minus lower we have the value. Remember, this is the observation that we observe from the benchmark, and these are the reading that we consider: 1.640, 1.920 and 2.200. These are the reading we need to consider while we consider a calculation of LC, that is the line of collimation, and the benchmark reading. So here the upper minus lower means that is the 2.200 minus 1.640. So that will be your reading, and the answer is 0.560. Okay, So this will be your staff intercept. Here there is smaller correction. I already told you need to put sine 2 theta instead of sine theta. Okay, so that is the sine theta value. So 1/2 k will be your 100, s that is the 0.560, and sine 2 theta, sine 2 theta is already given to you, that is the 1 degree and 6 minute, plus 0.3 and sine 1 degree 6 minute. That is the formula that we need to put the value. Now how to calculate? First multiply your angle with the twice and then calculate the sine theta, then multiply with this value. You will get the answer 1.081 meter. Okay, so this is your vertical distance from the LC to the your center reading. Now you need to calculate the elevation of that point. So simply benchmark is given to you. So for benchmark we know the RL is 418.685, the plus that is the equation height. Remember the value is given to you, that is the elevation of the instrument station plus h. In this case there is a no height of the instrument is given to you, so simply we can ignore the h point because we are going to calculate the elevation of the collimation. Okay, so that is the this will be your line of collimation. So simply 418.685 plus 1.920, that is the value we are going to add, that is the center reading, and minus your vertical height because we are going to deduct the value 1.081. Okay, this will be your elevation of the collimation at the instrument. Okay, here you can see that we are going to subtract the vertical height. In the above two equation we are going to add the value, but here you can see that we are deduct the value. We have an angle, positive angle, but still why? Because we are going to calculate this value, elevation of instrument station plus h. So if I just rotate, this will be your 418.685 plus v. So if we transposing it, it will be subtracted and r will be added. So that's why here we are adding the r value and we are going to subtract the v because we are calculating this two value. Okay, so the answer is 419.524. This will be your elevation of instrument plus h, means it is your line of collimation. Understood? So this will be your line of collimation for the instrument station A. Now we need to calculate the horizontal distance between A and B. So that is a simple formula, ks cos square theta plus c cos theta. So simply put the value 100, and for this we need to consider the reading observed at a B. So reading observed B at a B, that means there is a staff intercept is equal to 2.955 minus 2.255. Okay, so is equal to, we have our answer is 0.700 meter. So this will be your 0.700. Then cos theta is the given to you in the vertical, that is the 8 degree and 24 minutes. So 8 degree 24 minute square. Okay, plus c is equal to 0.3 cos again 8 degree 24 minutes. Okay, now again find the answer of this value. So the answer is equal to 68.80 meter. Okay, so this is the horizontal distance between A and B. Now same procedure for the vertical height that we already done for the observed reading at a benchmark. Same procedure, but this time we need to consider the staff intercept is 0.007. So point, that is the 100, then 0.7, and then put the value you will get the answer 10.160. That will be your in terms of the meter. Okay, now at the last you need to calculate the RL of B. So elevation of the instrument plus H we already calculated. This will be your line of collimation. So line of collimation is already calculated. Okay, so here you can see that the point is at a below level. So always remember your equation is used like this. Elevation of any point is equal to elevation of your instrument plus H if we have a positive angle. So or you can say the angle of elevation, then plus and minus R. Remember this will be when we have a angle of elevation theta, and we can put a minus when we have a angle is depression angle. Okay, so this is the formula you need to remember.